Nakamura-Tome understands thermal displacement deeply and also Navigator machine precisely, easily, efficiently.
What's really important is preventing the concentration of heat sources. The structure is simple.
This function accurately monitors temperature changes and make optional corrections. NT-Thermo Navigator AI.
Wow, it's incredible! Hello machinists! I'm Nakamura from Nakamura-Tome. So today, outside of factory, it's very cold. It's winter time. In winter and summer, many machinists concerned about one topic. What is that? It's thermal displacement in machine too. For example, temperature increase 1 degree Celsius. So what happens? The steel extends 10 micron. In micron level, the metal extends and shrinks repeatedly. As a result, this thermal displacement affects the machine accuracy and machining accuracy. Today, I will show you our NT-Thermo Navigator AI system for you. In NT-Thermo Navigator, Nakamura-Tome understands thermal displacement deeply and also Navigator machine precisely, easily, efficiently. NT-Thermo Navigator is not only the software, mechanical side, software side mixed together and make one solution. We can say traditional mechanical design and cutting-edge software technology, including AI, mixed together and make NT-Thermo Navigator AI for your solution. What is the result? Of course, it depends on the environment, depends on the machine condition workpiece, but this is the result with NT-Thermo Navigator AI. It's good result, isn't it? Do you want to know NT-Thermo Navigator in detail? So today I will show you. So let's jump in next machine. Okay, I arrived to the next machine. So this machine, NT-RX300. This is the machine bed of the machine. NT-RX300 is ATC type tool spindle machine, truly multitasking machine. High machine capability, very rigid machine. So today, I invited skillful engineer, Hiro Kuratani. Please come here.
Hello, machinists. I'm very excited to explain about our design philosophy for thermal displacement.
Okay, Hiro. In the multitasking machine, what is our design philosophy on thermal displacement?
Let me start by explaining machine bed. This is a bed of ATC multitasking machine NT-RX300. If you look at the actual bed, you'll notice it's large and simple. The spindle base is symmetrically, and the entire design ensures thermal displacement moves as expected. Also, the spindle unit is designed with a symmetrical structure.
Well, thank you, Hiro. The shape of the spindle box is very simple and symmetrical. Also, machine bed, it's very huge and simple structure. See? So in the multitask machine, it seems like to be more complex, but structure in the reality, it's simple. This is our philosophy, right? So let's move on to the next machine together. Let's go. This is new machine, NT-Y3100V, right?
Yes, that's right. First, let me introduce the NT-Y3100V, which we announced last year. It's a new 3-thread 2-spindle CN multitasking race. When we think about thermal displacement, most people first think about cooling or removing heat sources. However, what's really important is preventing the concentration of heat sources and making sure the entire machine moves in a consistent way. That way, it's easy to correct with software. This makes software composition more stable. As you can see from the machine, we focus on keeping the structure symmetrical and simple. For example, the motor is where the heat source is, but we'll notice it's not exactly in the same position. If you take a look at the machine from the side, You can see the heat sources are not same position as well. Besides the motor, there are other heat sources like the hydraulic oil in the chuck cylinder, the ball screw nut, sliding resistance. There are many heat sources when considering all the detail, but we've accounted for them and used simulation in the design.
Okay, even in such machine, the compact multi-touch machine, it's always difficult to put the motor right position. But in our design, we do positioning the motor concerning about thermal displacement.
Right.
It's incredible. Also, if we predict the thermal displacement well inside the machine, effectiveness of thermal compensation is more increased. Thank you, Hiro. Especially in multitasking machine, what's your challenge in the design field?
We don't just work with a single turret machine, but also 2 turret, 3 turret machines, and even outside spindle. So there are a lot of moving parts because that expansion and contraction happened in different areas. We go back and forth between simulations and actual measurement to see how the thermal deformation in one unit affects the tool chips and try to match theory with reality. It's a tough task, but because it's challenging, that is where the real difference is made. So we are all working together to make it happen.
Oh, tough task make the difference, right?
Right?
So Nakamura-Tome accumulate lot of know-how for multitasking for over the 75 years, and also now install new technology simulation for thermal displacement and mix together. It's incredible, Hiro. So thank you, Hiro.
You're welcome.
Let's move into the software aspect. Let's go. Okay, now I'm in front of JX250. We would like to explain the software thermal compensation. So today I invited the person who know the software side very well. Marin, please come.
Hello, machinist. My name is Mari.
So what's the future of Nakamura-Tome thermal compensation software?
Nakamura-Tome's machines are equipped with our original thermal displacement compensation software, Thermo Navigator AI. This function accurately monitors temperature changes and make optional corrections to ensure high precision machining, even with significant environmental changes such as in summer or winter. It automatically adjusts to optimal parameters without requiring manufacturer intervention.
Okay, Marin, I'm really interested in the future. So, what is the point for the sensing thermal displacement?
First, all machines are equipped with temperature sensors that continuously measure the temperature of each unit, motor, frame, internal and external environment, and so on. For example, the JX250 monitors temperature at approximately 20 locations in real time. Nakamura-Tome uses its experience and know-how to decide the best spots on the frame and units to measure temperature. The machine analyzes how much each part moves based on this temperature data and adjusts itself accordingly. This system is called Thermo Navigator AI.
Okay, the sensing position is also very important know-how, right? That data collection looks like very simple, just putting sensor on the machine, but it's very deep technology, I know. So in the factory environment, in the summer and winter, that is a big difference inside the factory. Also, in our customer factory, our customer use multitasking machine and make, for example, more than 100 types of workpiece. So what's your solution about software side, that big difference in the environment?
Yes, that's right. If the environment is stable, Thermo Navigator AI can handle machining with the factory settings without thermal displacement issues. But if the temperature or conditions change a lot, some adjustment may be needed. This is where Thermo Navigator AI helps. Over the past 20 years, Nakamura-Tome has collected thermal displacement data. The software stores the best adjustment settings for each case, and the AI suggests the right settings for stable production.
How exactly does it work in the customer's factory?
First, click the NT Sub Navigator AI icon button here. Here you enter the dimensions of the parts you are currently producing and the time each part was machined. Basically, this is all we ask our customers to do.
I wonder, normally AI requires big data, but in this system, is it different?
You just needed to collect the data until the dimensional changes begin and stabilize, and that's enough for data entry.
Once the input is done, so the parameter is automatically tuned, right?
The software adjusts the thermal displacement based on the data and dimensional changes entered. The red part of the graph shows the current dimensional changes, while the blue shows what we expect after the adjustment. As you can see, the blue graph is more stable. Then press Reflect to update the internal settings. What's interesting is that this data can be saved, so users can switch between summer and winter settings when the plant environment changes.
Okay, Maureen, that's really nice idea. You save the data in the NT Sub Navigator AI, so we just pick up the summer and winter data again in the next summer, so we don't need anything, just press a button, right?
Yes, that's right.
Wow, it's incredible. This is a good function, good system. I think it is expensive.
Shogo. This feature is standard on NT Smart X, NT Smart XS, and Dell ITF Plus controls. In other words, it is a function that is included free of charge in almost all Nakamura-Tome machines.
So it's very reasonable. You install our multitasking machine. It's me, you install NT Sub Navigator AI. AI install in your factory. Your Sub Navigator AI navigate your machine precisely, easily, efficiently. It's also very clear. Machine design is very important. Simple and symmetrical structure make thermal compensation more effective. I hope you enjoy NT Sub Navigator AI in your factory and cut the burden of manufacturing. So everybody, if you like this NT Sub Navigator AI, please subscribe and press high rating. See you, machinists. Bye.